Hi, hey, hello everyone.
Hi, sir.
Hi,
Hi, sir.
hi, hey Rajita. Hi, Nikita.
Good
Hey,
evening,
okay,
sir.
good evening. So once again, like before, I will request you guys to turn on your camera. Give me just a moment, and I will um, share the screen. Basically, it just has the homework stuff, so nothing too fancy. So, and while we get started, right, any comments? I'm assuming that all of you have done the homework and have submitted your homework, right? Just in case anybody missed out, then this is a good opportunity right now to kind of submit your homework. All you have to do is, okay, first let me share my screen. Okay, oops, wrong course. Let me connect it back. Okay, it's right here. Well, zero to silicon. So you probably see this, right? So in this, you just go to this assignments, right? And submit your, yeah, any question? Okay. So you just need to go to week two, submit week two assignment, right? So in that, oh, only 6 people have submitted. Um, this is quite critical, right? Because assignments do carry 20% weightage for your final score. So it's really important if you can submit it, right? Um, okay, of course, if you haven't submitted this by the time the class is started, then that'll be a bit too late. But if any of you want to do it right now, I would highly recommend you to do it. And definitely next time, I'm hoping that we will have much more people doing the homework. It's really important, right? Because only by doing this, you will learn and practice. How much ever you listen to the lecture, right? It's going to help little bit, but not much. You have to try it, right? It's like we can't just watch cricket and suddenly become good cricketer, right? We have to go and practice. So in the same way, we absolutely need to practice. Okay. So right now I see only 6 of you have submitted. I strongly recommend at least from next time all of you to kind of submit your assignments, right? And and also Mohana Krishna, highly request you if possible, right? Try to submit it as one picture or one document. It's okay for now. For this time, it's perfectly fine. But otherwise, it's actually quite difficult or painful to correct it. Okay, no problem. Let's jump right into the homework. So let me just say edit assignment, and then that'll open up the homework right away. And then we just go here. Oops, assignment is not here. Assignment is with the material. Okay, now I know where it is. Sorry. Let's go to the content and week two assignment. And we can go full screen on this. Okay, so we will review and do each question today, right, in class. So today's class is to really go about doing this, and the assumption is that you would have already kind of done it, right? Okay, hey, no problem. We will get started. Okay, so the way I would like to do this today, right? Oops, not like this. I need to, can I? Wait, why won't it? Let me zoom in. Oh, it has its own way of zooming in. Okay. Because I just want to focus on the one homework. Okay, one question at a time. Okay. So I believe at this moment you can see the first question, right? So we will go ahead and sort of do it. But what I would like is, all of your help. So I want you all to participate in doing this again, right? Hopefully, if you have done it, then of course it'll be easier for you. Even if not, right, at least try to participate since many of you have not submitted. Please take this opportunity at least to do it. But I would still recommend, even after today's class, when we have sort of done the homework, please attempt the homework and at least submit it even after the class. We will at least give some credit, like 50% or something, because otherwise you will get zero for this homework, right? That's not good. Okay, so let's take the first problem, right? So always my recommendation, and this is some tips and tricks I learned that work for me for competitive exams or just in general, looking at any problems and so on, right? So the first thing I strongly recommend is when you're given a problem, sort of look at the problem and try to, see what are the points you can gather, what you understand about it, what are main things you can tell, okay, hey, this is happening here, or this is it, or whatever, right? So that's what we need to do first before starting to, working on solving the problem, right? Solving the problem, we discuss the steps and we will certainly do it. But the first step is to sort of understand how we go about this. Of course, this problem we had sort of done very, very quickly last class itself, but still, so my question to you guys, right? And please feel free to stay unmuted or you can unmute whenever you want to talk, right? So what are your first impressions, right? When you look at this, how do you think of this? Maybe any of you can answer for me. Like, what do you see in this problem? How do you think this circuit might be behaving? What do you think you may need to do?
Basically, I took it as two loops, sir.
Okay.
One loop from A
Two
to
loops.
B,
You're
and
saying
then
there are
another
two
loop from.
loops?
Yes, sir.
Where do you see two loops?
Me
Sir,
also
this.
doing same, sir. Did same, sir.
Wait, you're saying you see two loops?
Yes,
Yes,
sir.
sir.
Okay. Okay, so
Actually,
let me just start drawing, right? I see one loop, right?
yeah,
And you have to now tell me where is the second loop.
It's A, B, D.
there is no
ABD is
resistance.
not a loop, right? You have to come back to A, then only it's a loop, right? If you
No,
start
then
from A,
only one loop is there.
Yeah,
yeah, if you start from one point, right? Let us say I usually was starting here in the class, so I'm keeping it consistent. Of course, you can start from here as well. But if you start from one point, you have to go around a loop. And you call it a loop only if you come right back, right? If you don't come back, it's not a loop. Okay. So the first thing you'll realize is, hey, there's only one loop. Each and every device is in series here, right? All the devices are in series. Do you see that?
Yes, sir.
Okay. So basically there is only one loop. So this is one thing we kind of immediately recognize, right? Then we notice something really fishy, right? Which is this stuff. So, okay, voltage source, we are very happy with. Resistor, we know. Resistor, we know. I mean, I'm not analyzing it. I'm just saying, hey, okay, I see voltage, resistor, easy stuff. I'm very happy. What is this strange stuff, right? Then you have to pay attention. 10 VR1. So is it clear what is this element?
yeah, independent voltage.
Independent voltage source, correct. It's not independent, it's a dependent voltage source.
Dependent. Yeah,
But it's a
yeah,
voltage source, right?
Yes.
So it depends on which voltage. This voltage depends on
We are
VR1.
this
VR.
VR1, this resistor voltage, right? So whatever be the voltage drop on this resistor, right? 10 times as much is going to come
we are
here, and it's going to be in this direction, plus minus like this, right? So this is what this means. Okay, not bad. So okay, we sort of understand what this means. So this is it. So I'm saying two observations if you take away from this, right? One, there's just one loop. All the elements are in series, right? And the second thing is you sort of understand what is this VR1. Then I think you can start solving the problem. Okay. So this is my suggestion. Of course, you don't necessarily need to think like this, but if you think this way, right, you'll find it much easier. So you have understood the problem. No, what we said, we are going to mark the current and the direction, right? So let us say I mark the current as I. Okay. Now, given that everything is in series, right? It is the same current I and the same direction. I should not change it, right? Don't go changing here and call it I like that, right? That'll be wrong. So you shouldn't do that. So I, and okay, it's not really important, but it's I, right? So basically it's the same I going all around, correct? So that is good. And then how do we mark the voltages? Well, we said the tail must be plus. Already there is a plus here. In any case, if it was not there, we would say plus minus. We would say plus minus, but for you, this is already shown, right? Here, the plus minus is already shown, right? But if you want, you can write it outside or you can leave it. You don't need to write it, right? It is there. And here also plus minus is shown. You don't need to write it, right? So it's very simple. All we have to do is write. What do we need to do here? Which rule? ACL,
K-
KVL, what?
KVL.
KVL, right? Okay. So I want all of you to help me write KVL. Which point shall we start? Shall we start with D? Shall we start with A? Where you want to start?
12
From
volts.
A.
A. Okay, let's start from A. Okay, so if I'm going from A and let me go clockwise, right? I'm going in this direction. So please tell me what should I write first? So should I
Minus
write
VR1.
minus
No,
VR1? Okay.
Minus VR2.
Okay.
Minus 10 VR1.
Minus 10 VR1
Plus 12 volts.
is equal
is
to 0.
equal to 0.
Equal to
Okay,
0.
very good, right? And then do you have any other information right now?
VR2 is 1 volt.
VR2 equal to 1 volt.
Excellent,
Voltage.
excellent, excellent. Okay, so let me kind of move this down, right? So basically this means I can further, and if I combine minus VR1 and minus 10 VR1, right? I can sort of say, hey, minus 11
VR.
VR1 minus 1 volt, right? Plus 12 volts is equal to 0, right? And I can, of course, move the 11 VR1 to the other side, and 12 minus 1 is 11. So I will have 11 equals 11 VR1. Do you see this?
Yes,
Yes.
sir.
Okay, perfect. So VR1 is
1 volt.
1 volt.
good answer, right? Correct answer. VR1 is 1. Okay. So what did the question ask? That is, of course, another thing we should have checked first.
VBD.
VBD
Kind of.
we need to know, right? VBD, that means what is the voltage of B with respect to D? That means with B as plus and D as minus, what is this voltage? I can go like this or I can go like this. Both ways I can get it, whichever way is easy for you. So let's go like this first, right? So please someone help me. What is VBD? So the way we think of it is you think of this as an imaginary voltage source, right? Not a short circuit, an imaginary voltage source called VBD. Okay. So, and then we do the KCL starting from here. So when I go minus to plus, what should I do?
Plus.
Plus VBD. Then when I go from plus to minus, minus, right? Minus 1. And then what about this one?
Minus 10.
Minus 10 VR.
And VR is 1, right? And I'm back to D, correct?
Yes.
Right? So VBD is equal to 11. Okay. I think this was pretty straightforward, right? Anybody having questions? Okay, so if no questions, we'll quickly move on to the next problem. Okay. And sideways. Oh, okay. Okay. Let's go to this. Uh-oh. Oh, I can't somehow. Okay, no problem. We will just work through this again. So let's look at this problem now, right? This one. Again, initial impressions, right? So anybody can just unmute and share your initial impressions. Maybe this time I will ask someone else, huh? So maybe Nikita, you can share your initial impression of this circuit. What do you think?
It's a single loop.
Yes.
So we can apply KVL. First
Okay.
of all, to find the current. Then we can look for VBD.
Okay, great. So what you're saying is, look, there's easy stuff. There's two resistors, two voltage sources. Everybody is in series. I can just apply KVL. I'll figure out the current. And then once I know the current, I can compute the voltage, right? Very good answer. Let's actually do it. So that's it. That's all we need to do, right? It just takes a few seconds. Sometimes, 10, 20, 30 seconds. You just stare at a circuit, try to draw conclusions in your head, right? And then immediately jump in. So since there is only one loop, we can say, let's say the current, right? Let's assume a direction. Would you say the current would be like that? Or would you give it the other way? Maybe Nikita, you can tell me. So is this a good direction for
Same,
current, right?
same way we can take it.
Yeah, so this way. So I just going around clockwise, right? Okay, good. And how do you mark the voltage across the resistors? Maybe now I'll pick on somebody else. So maybe Mohan Krishna, maybe can you tell me how you will, where is the plus? Is A on the plus side and B on the minus, or A is minus and B is plus?
Yeah.
Oh, you're on mute. Can you unmute? Please tell me.
Sir, A and plus, sir.
A is plus. So you're saying it's like this, right? Okay. How about the second resistor, 40 kilo ohms? Is C plus or D plus? Which way? Is it plus on top or plus on the bottom?
Plus on top, sir. C plus.
Plus on top, plus and minus, like this, right?
Yes. Yes, sir.
Okay. That makes sense because the current will be going like this. The tail is always plus, the head is always minus. Perfect. Now please help me with the KVL. Can you please tell me the KVL for this? From which point shall we start? A, B, C, D, which is your favorite starting point?
From A.
A.
From A. Okay, everybody likes A. Okay, very good. A. Please go ahead, tell me.
80K into
80K into I
I plus
plus, okay,
plus 12 volts.
plus 12 volts, okay,
40K into I
plus 40K into I
is equal to 6 volts.
equals 6. Yes, you could certainly do it like this, right? So in this case, Mohan Krishna has sort of gone the opposite way. So, he is taking plus to minus as a positive side, right? So he got a bunch of positives and he's taking this as negative. So it should have been ideally minus 6 is equal to 0, but you can also put the 6 on the other side in one step.
So one small
Yes.
doubt, sir.
Yes.
We are indicating the current through the arrow, right? So when I
Yes.
draw near 6 volts, if I draw an arrow near 6 volts, the bottom will be positive and top will be negative, right? But given it is reverse, so which one should I consider while writing the KVL?
Right. So the thing is, this thing that I told you that always the tail should be plus and the head should be minus, right, is only for resistors.
Okay.
So if you have a current and a resistor, it only applies to that, right? Everybody else, this rule is not necessarily applied, right? Maybe you can also extend it. Other devices, they can have, their directions mixed up. I mean, not mixed up, can be in any way, right? And also one thing if you do is if you do take the current, let's say you have an inductor and if you take the current like this, and if you put plus, minus and V, right? Then you can say, V is equal to L di dt, it will work correctly, right? Similarly for capacitor, right? If you follow the same convention for the resistor, then you can say I is equal to C dV dt, that will work. Then there'll be no mistakes, right? But these are all, for example, a resistor is an element that consumes power, right? So when you have current going like this and the voltage drop is plus minus in this way, right? That means this device is going to consume power. Okay. But a voltage source is the opposite. Voltage source is giving power, is giving energy into the system, right? So in this case, the directions will be reversed, one of them, because voltage into current is the power it is giving, right? So if this is sort of negative or positive, if you say positive means consuming power, then the voltage source will be negative because voltage source won't consume power, it will generate. Okay, that is why, and which means I think you got it, but the answer is for KVL, always use the plus minus, what is shown.
Here in this is equal to -6, it will come because it is going from minus to plus, right? It's
Correct.
140 Ki plus 6 is equal to 0. If 6 that side, it has to
It's
be
actually, we should have said -6 equal to 0, right? This is the correct way to do it, right? So, and what we would have done, right? If I would have done it in class, how we were doing it until now, I'm not saying that's the only way. We were
No, it's
doing it
plus
like,
6, right, sir? It is going from minus to plus, so we need to take plus 6, right?
right. So maybe I want you to help me, right? And I think you are going also correctly. Let us start with D, okay? And please
Yeah.
help me do a KVL. Let's go around, right? This loop, okay? So we'll
It's
start with plus 6 volts for this, right? And please
okay.
tell me the rest of it.
Minus 80
Mi-
Ki,
Minus 80K
80
into I,
Ki,
okay?
minus 12 volts,
Minus 12 volts, okay?
minus 40 Ki is equal to
Minus
0.
40K I equals 0, right?
0.
So
Yes.
what you will find is very good. And you will find that both these equations are actually correct, right? So what will happen is if I take this entire equation on the other side of 0, right? If I move all the terms on the other side, you will find that I will get back equation number 1, if I call it 1 and 2, right? So 1 is nothing but I have taken all these on the other side, right?
Yeah.
Or I have multiplied.
Got
So basically, we are just doing it in an opposite convention. To be very clear for the whole class, the entire class until now, I was following number 2, right? In this case, for some reason, Mohan Krishna is used to number 1. This is okay. If you are clear, just follow one consistent way. Don't mix the two, right? Then you will get wrong answers. But both are correct. Both will give the
Yes,
same
sir.
result, right? Okay. So now let's quickly kind of solve this. So we'll take 6. We'll leave 6 here. We'll move the others to the, sorry, 6 and 12. We will leave them here only. And the rest 80K, 40K, we will take them to the other side, right? And let us do that. And what will we get? We will get 6 minus 12
120.
minus
120.
6
Yeah.
is equal to 120K times I, right? So I is
Yes, sir.
equal to
minus 0.05
Minus 0.05 milliamps.
milliamps.
yes, 120 milliamps, right? That's what it is. So 6 and 20 you can cancel. It's 1 over 20, right? And you are correct. 1 over 20 is nothing but 0.05. So 50 microamps, right? 50 microamps, or you can say 0.05 milliamps, all correct answers, right? So now we know what is the current, right? So now what was the next question? We need to find VBD, okay? Let me erase everything. I'll just note back this 0.05, right? Just to avoid some confusion. So we said the current was, let's just say 0.05 milliamps, right? And now we need to find VBD, okay? So Kavya, I will take your help again. So how did we say we will do it? We said, hey, put an imaginary voltage source, right? With B as plus, okay, and D as minus. It says VBD, right? So B should be plus, D should be minus, okay? And now we need to find this VBD.
Yeah, we can do 6 volts minus 80 Ki so that we can
Okay,
get
so
VB.
you're saying let's follow this loop,
First
right?
loop. Yeah.
So I want you to help me do the KVL. Please tell me KVL according to you, how we will go. So you're saying do 6 volts
Yeah,
minus
6.80
80K
I
I, and then what do you
is
do after that?
equal to
For
VBD.
VBD is going to be plus or minus?
Plus. Huh?
So when we
Minus
go
VBD.
Minus V is equal to 0.
minus VBD,
VBD is equal to 0.
0, like this, right? Kavya,
Yes.
you also agree, right?
Yes.
Okay, because we went from plus to minus, we still keep it as minus. okay? Because minus to plus was. That's it. So if I want to find VBD, I move VBD to the other side of the equation. So I will get VBD is equal to
10
all of
volt.
this, right? So yeah, 6 minus. Hey, wait, I'm sorry. Last time I remember, wasn't it minus?
Yes, sir.
Yes,
Yes, sir.
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 Minus,
Yes, sir.
minus. Yes, sir.
It was
Yes,
minus,
sir.
right?
Minus.
It's very
Yes.
important. Please
Yes.
do not forget minus sign, okay? It's very dangerous otherwise. What minus means is that you can still call this plus minus, but in reality, the voltage is higher on this side than here, and the current is not flowing like this, current is flowing backwards, which is okay, right? So we just put a minus over here. So 80K into 0.05 milli. K and milli will go away, right? 80
Yes,
into
sir.
0.05, right? So it is 4,
10.
right?
4.
And that too
10
minus.
volts.
I mean, minus of minus, so it will become plus.
Plus
That's how
10
you get 10
volts.
volts. Everybody is clear, right?
Yes, sir.
Yes,
So,
sir.
Yes,
so
sir.
if you reported the current as plus 0.05, it will be wrong answer. Okay. So you should correctly say the current is minus, or if you had picked the direction to be like this, right? Then you're okay. So, and how you could have guessed that, right? Now that you solve this problem, you stare at this circuit again, right? What do you see? You see, hey, there are two voltage sources, 1 and 2, right? Because we are used to looking at the voltage source on the left to be the dominant one, we just looked at it and took the current direction based on it, right?
Yes.
But which is the bigger voltage source?
12 volts.
12 volts is bigger, right? 12 volts is going to decide where the current will flow, not 6 volts, right? Because 12 volts is more than 6 volts, correct? So what will actually happen, which we found out, was the current will actually flow like this. So if you assume that the current was flowing like this, and you wrote the answer as 0.05 milliamps, you are 100% correct. Or if you assume the current was like this and you reported the current was minus 0.05 milliamp, also 100% correct. Okay. So the moment you find that the current is negative, what it means is whichever direction you assume, that was wrong. Current was going in the other direction. Okay. Clear, right? Okay, great. So I think these problems were easy. So far, only single loops, right? So let's go to this third problem set. Let's see if we can zoom in a bit and not lose this problem. Okay, this is good, right? So maybe now I'll move on. So maybe Asha, you can help me with this problem. So what is your initial assessment, right? When you read the problem, it says find currents I1, I2 and power absorbed by the 40K resistor, right? Okay. So, and you look at the circuit and what are your thoughts? What do you think might be happening here?
Yes, sir.
Yeah. Any initial thoughts? I mean, of course, we will solve it, right? We can't tell the answer by just staring at it. I mean, maybe we can, but let's not get into that, right? So, how do you,
Act- Sir, actually, that question also I have some doubts.
okay, you can ask your doubt. Go ahead, please.
You know. At upward, I take the one node.
Okay, this node.
Yes, sir. Yes.
Okay,
Enter the current directions. One
okay,
is 40K is I1,
yes,
and other one is leaving the current I2, sir.
correct, correct.
And
What is your
equal to
question?
6. Equal to
You're
6
saying you
volt.
will write KCL for
Yeah,
this
yes,
node.
sir.
Yeah,
Yes.
yeah. No, I'm saying let's not start solving. Any thoughts, right? So first of all, you'll notice that yes, here we need to do some kind of KCL. There is almost nothing in series. Everything seems to be in parallel, right? So yes,
Yes.
you can say there are two loops, but keep in mind that KVL is not going to help you when you have a current source. Why? Because current source can have any voltage across it. We discussed it, right? So
Yes.
where KVL can help you, which is definitely there, is this loop. right? I hope you see all three loops. So loop 1, loop 2, and the grand loop 3, right? So
Yes.
1 and 2 KVL is not going to help you much because it will just tell you that the voltage across the resistor matches the current source. But you can't tell what is the voltage on the current source. That's not easy to determine, right? So that
Yes.
equation is not useful, right? So if
Okay,
you
sir.
want some relationship between I1s and I2s, you probably want to look at this big KVL, right?
Okay, sir.
Okay, so great. Now please help me understand how to solve it, right? So first thing what we will do, and Asha, please help me with this. So we will mark the currents, right? I mean, I know it's already marked in the circuit, but it's hard for me to read that little arrow. And this question is really tricky, right? Very mean people. Why did they give the current for I1 and I2 in opposite directions, right? That's really silly. I would think that they should not be in opposite direction, but hey, who am I to question the homework question, right? So let's mark it. I1, I2. Okay, I shouldn't change the variable. I should leave it as caps. Okay, I1, I2, right? And you are very correct, Asha. Your intuition was good that, hey, I should come to this net and write the KCL. So please tell me what will be the KCL equation? Maybe
I
we'll first put current coming in. What is the current coming in?
I1, sir.
I1. I1 is equal to, what is the current going out?
I2, sir.
I2, any
I2
other current
plus
going?
and 16 amperes.
16 milli. Let's just write
Yes,
milliamps, right?
amperes.
Or let's write milliamp, the whole thing. It's okay. So I1 is equal to I2 plus 16
Yes.
milliamp. Okay, very good. What else? We need one more equation, right? Because we have
Yes.
two variables. Okay. How do you think we can get the second equation?
I1 plus I2 is equal to 16 milliamperes.
How do you get that?
A1 minus I2, sir.
That is the same equation, right? In
Yeah,
this
yes, sir.
equation, if I move I2 on this side, I will get I1 minus I2 is 16. Okay, that is nothing. That I already have that equation. I need one
KVL
more
bigger loop.
equation.
KVL for bigger loop.
KVL.
Very good
KC.
answer, Asha. So now you are going to help me. Of course, one thing I forgot. Sorry about that. I broke my own rule, right? So if the current is going this way, please help me with plus and minus for the resistor. So this time, Asha, you need to do it.
Yeah, minus to plus.
So
Sorry,
you're
sir.
saying bottom is minus, oh, top is minus and bottom is plus, correct?
Yes, yes.
Okay, and over here for 120K top is,
Plus,
and bottom is minus, correct?
minus. Yes, yes, sir.
Okay, very good. So please help me with KVL. So are you going to start from the bottom and go clockwise or start from the top, go, how you want to do it? Tell me.
So could you explain again?
Yeah, so for the KVL, right? Now we need to apply KVL through this big loop, right?
Yes,
So
sir.
where are you going to start? And are you going to go clockwise or anti-clockwise? It's your wish.
Yeah, clockwise, sir.
Clockwise, and you will start from which point? You'll start from here, where you want to start? It's just your choice. You can start from anywhere. Yeah.
Current direction up, downwards.
Yeah. So you'll start from this point, bottom point.
Yes.
Okay. So please tell me the KVL starting from this bottom point, going in a clockwise direction. Yeah. Please tell me.
Yes. Minus V by
Minus
40K.
minus 40K I1. Okay. Now you reached here. You finished this much. Then
Plus 16.
Plus
no, the big loop, right? You don't know the voltage on the 16 milliamps, so leave that, right? So
Yeah.
you will take this and then you'll come here and you'll go through this, right? So
Yes.
what is the
Minus
voltage drop? Yeah,
minus 120K ohm into I2.
I2 is equal to,
16 milliamps.
no, is equal to 0. This is KVL,
Yeah,
right?
yes. Yes.
Yeah. Okay. So this is the second equation, right? So that's it. So let me simplify the second equation. So 40K I1 and 120K I2, right? I can divide both by 40K. Okay. And what am I going to get? I'm going to get, and I can divide by minus 40K. So then I will get I1 plus 3 times I2 is equal to 0. Okay. So I have two equations. One here and 1 here. Let me call this as 1 and this as 2, right? Makes sense, right? Let me actually just, put it on a better thing to write. Sorry, just give me a second. Let me get something else here, just a blank slide or something this way. It's just going to be much easier. Okay, let's just use this, right? And whoops, there is still a bunch of stuff I have drawn. Let me I mean, I remember these equations, right? So anyway, I have this one equation. Oops. I have this one equation and the other one, right? So now let me solve it. I'll write the two equations over here. I1 minus I2 is equal to 16. I1 plus 3I2 is equal to 0, right? So how do you solve this? Very straightforward, right? I just add them up. I will get 2I1 is equal to what? Oops, I shouldn't add them up. Sorry. I subtract them. Sorry. I subtract them, right? This
Plus.
minus this. So basically, I will get minus 4I2 is equal to 16. So I2 is equal to minus 4
Minus 4
milliamps.
milliamp.
Minus 4 milliamps, right? Okay. So I can substitute this anywhere, right? I can substitute this minus 4 right here in this equation. So I will get I1 minus 12 milliamps equals 0, which means I1 equals 12 milliamps plus 12, right? Everybody clear with this?
Yes, sir.
Okay.
Yes, sir.
In fact, I don't even like this. I'll go with this. Much better. Okay. So now let me go back to the presentation, not presentation, that one, and that one, and let me erase everything. So we got 12 and minus 4. Let me erase everything. Okay. Let me come down to that. So this was 12 milliamps. This was minus 4 milliamps, right? And you will see that, of course, both will be flowing in the same direction. Basically, 16 is supplying the current, 12 goes on one side, 4 goes on the other, right? So the I2 direction shown in the homework problem was wrong. I mean, not wrong. Basically, the actual direction is opposite. Because if you call this the direction, then the current is minus 12, minus 4 milliamps. Okay. Maybe one other way to think of it is 40 kilo ohms is nothing but 3 120K in parallel, right? So now imagine I had 3 120K in parallel and I had one more 120K in parallel and I had a 16 milliamp current source. What will happen? Of course, the current will go equally in all four because all the four branches are equal, right? So immediately I can say, oh, it's 4 milliamps each. Okay, since 40 kilo ohms is nothing but 3 of those together, that is 12, and this is 4. So it still makes sense. This last part, is it clear? I know I kind of jumped a bit, but you
Yes.
see that, do you agree that 40 kilo ohms is 3 120K in parallel?
Yes, sir. Yes, sir.
Yeah. So the reason I chose 120K is because this was 120K, right? And then I have
Yes.
a fourth 120K in parallel. And then I have the 16 milliamp current source, right? So of course, if all are equal current is going to go. If I divide current in 4 ways, it's going to be 4 milliamps, right? So immediately I can tell, oh, okay, there's 120, there's 4 milliamps going on this. Of course, this is 4 each. So if I combine them together, there's probably going to be 12 milliamps. You don't have to do this if it's confusing for you, right? But if you follow KCL and KVL each and every time, you'll get the correct answer properly. Okay. So we did this problem. Let's now move to the other side. Oh, this is a bigger problem. Thank you, Asha. Really well done. Okay, next I have Pratyush Babu. So Pratyush, if you can unmute, ideally turn on your camera, but if not, If you can tell me what are your thoughts, we'll take your help to kind of solve this problem here.
Yes, sir. Can you
So,
hear me, sir?
yeah, I can hear you. So what are your initial thoughts?
Initial thoughts. Mm, I have one resistor parallel with the current source.
Mm-hmm. Not one, right? Yeah, one,
Not one. I have
three.
a three pair of one resistor parallel with one current source. Can I change it to can I use source transformation theorem and then solve it?
Sorry, what transformation theorem?
Source transformation theorem.
Source transformation. Okay. And what are you transforming?
I am transforming that is 18 kilovolt and 1 milliamps. I'm saying that is my approach. Whether it is possible to solve by this
But
approach.
I'm not understanding your approach, right? So what are you doing in the transformation? Can you explain? Are you converting this whole circuit into something else? What are you
I'm
doing?
converting this pole into voltage source instead of current source, so that I get a one series circuit.
Okay. So how do you convert this into a voltage source in series?
Like
You're saying
now,
you're going to take these two, right?
yes,
And you're
these
going to
two,
convert it
and
into the same resistor, right? Plus a
yes, the
series
same.
voltage, right? But what
Yes,
will
that
be
is
that series voltage?
that is 18 kilovolt into 1 milliamps.
Okay. Okay. And which will be the direction of it?
Direction is
And
Minus
I'm
plus
not saying it's wrong, right? You can do it. But let me tell you that it's a correct way, but there are some dangerous steps here. If you make some mistakes in those steps, right, you will get the wrong answer. But that's okay. What would be the simplest way, right? See, I have first thing I notice. Tell me if you also notice the same. All
all
elements are in parallel, right?
Parallel,
Yes.
yes, sir.
yes.
Yes, everybody is in
Current we
parallel,
can
right?
find.
So what happens if I have current sources in parallel, right?
We can add it.
so we can apply
Yes.
KCL.
1 minus
Of
4
course, we can
plus.
apply KCL, but we can also, okay, so I'll
Oh,
ask you a
okay.
different problem, right? I will ask you a problem like this. I have a circuit which has three voltage sources, minus, plus, minus, plus, plus, minus. Let's say 2 volts, 3 volts, and 4 volts, right? How will you try to work with this circuit?
2
Can you
minus
combine
3
all
plus.
three into one voltage source?
Yes, sir.
Yes,
Yes,
2
possible.
plus
Absolutely, right?
3.
That'll be the easiest thing to do. I mean, that's also a transformation and that's the easiest transform, right? So you can just add
Yes.
up these voltages. It'll be 2 minus 3 plus, oops,
2 plus 3 minus 4.
2 plus 3 minus 4. I'm sorry. Thank you. So it'll be 1 volt in this direction, minus plus, right?
Minus.
So I can replace all these crazy voltage sources with a single voltage source equivalently as minus, plus, and it's 1 volt, right? And 3 elements gone, I'm left with 1, right? So you can do the same thing with current sources in parallel, right? So what will be the one current source that you can, effective one that is left after you have combined the 3, right? 1 is going up, 2 is going up, 4 is coming down. So total 3 is going up and 4 is coming down. So the net
Minus
is
Minus
Minus
1.
1.
minus 1 or 1 going down, right? So what I can
Yes.
do is
Yeah.
I can sort of knock this off. I can knock this off and I can change this to 1 milliamp, right? And I'm done, right? I don't have to worry about all these current sources and crazy KVL, which is fine if I want to do it in one shot as well, like do the KVL without equivalent, right? And then if you still want to do equivalent, you can take these 3 resistors, you can find the effective parallel combination, right? We discussed that, how to do that, right?
Yes, sir.
So this is one way, but what I would recommend, since I'm teaching you KCL, KVL really works, right? Let's apply it. So let's apply KCL on this top node. But before applying KCL, right, we have to sort of assume some things, correct? So we have to assume currents and voltages. So can you tell me on 18K, do you assume the current to be going up or coming down?
Going up.
Going up.
Good choice. How about 9K?
Down.
Down.
Why down?
The
You can
node
consider that also up.
parallel 4
Up.
amps, 4 milliamps is going
So,
down.
so what you're saying is, oh, this 9 is closer to 4, so it'll follow the direction of the 4. This 18 is closer to 1, it'll follow. Is it like that? No, this is not true,
No,
right? These
it's not.
parallel sources are anyway independent. We anyway figured out that effectively the current source is pushing current down, right? If it is pushing current down through the resistors, the balance current must split and just somehow come up, right? And whichever one direction you pick for the one resistor, right? Pick it in the same way for others. I will tell you why. And we saw this in the previous problem. Let us say this voltage is plus minus, example. Wait, this is wrong. It's plus minus, right? Because of our direction. Now, do you think this can be minus plus or this has to be plus? Because it's in parallel, right? The exact same voltage, whatever is over here, should be over here. So it is best to pick one direction for all the parallel resistors, right? Assume the current is going in one direction and just stick with it. You can pick up or pick down. If you by chance pick the wrong direction, you will get a negative answer, which is okay. If you luckily pick the correct direction, even better. Okay. So my recommendation, right? If you recognize that this 1, you're going to crash, this 2, you're going to crash, and this, you're going to make it 1 milliamp, you're in very good shape, right? Because now you reduce your 3 current sources to 1 current source, which is pushing current down. That means the current will come down, it'll split into all these branches, right? Based on the resistor. Correct. So now it's really easy. So let's assume the current goes up, goes up, goes up, right? Now here, of course, you can do something that I told you before that'll help you. But if it's too complicated, don't do it, right? That means 9K is nothing but 218Ks in parallel, right? So if I call this I, right, you can call this 2I, and that's perfectly fine. But let us say you didn't recognize it. You're like, you didn't think in that way, which is nothing wrong with it. Let's call this then I1. Let's call this then I2. Okay, let's call this then I3, and let's call this IL. It's already there. And this IL is actually coming downwards, right? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, which is fine. Because the other resistors going up, we know that this IL is going to be negative, right? That's okay. Let's solve it, right? That's fine. So how do you solve this? Now you have this. First, tell me KCL. So Pratyush, please tell me KCL at any node, either the bottom node or top node. Please tell me the KCL for this. What are the currents coming
call it
into the node?
I1 plus
Okay.
I2 plus
Okay.
I3. Which is
Okay,
equal
good.
to plus IL equal to 1 milliamps.
1 milliamps plus
IL.
IL, right? Why? Because IL is going down, correct?
Down.
It's going down. I shouldn't draw this arrow like this, correct? So this is my KCL. I1 plus I2 plus I3 is equal to 1 milliamp plus IL. Okay, very good. Now we need to mark the direction of the voltages, right? Plus to minus, plus to minus, plus to minus, plus to minus, plus on top over here. Okay, so now what do we do next?
We go for KVL, sir.
Very good, very good. Which KVL should we do?
In the first near the first loop, sir, between 18K and
18K
9K,
and
sir.
9K.
Yes, how nice. Okay, we'll do this loop, right? So please tell me what will be the KVL for this?
Minus 18. So
Sir, I have a small doubt.
Yes,
Why you change the direction of polarity for resistors, sir?
I changed. What did I change? We just assumed, right? We decided to pick one
Okay.
direction. I just picked going up.
Okay.
Yeah, we shouldn't change it in the middle. We should fix one, right? We could have taken all of them going down, looking at IL. Nothing wrong with it, right? That would have been fine, except we would have, or we picked up, right? So either way. Okay, so please
Okay,
help
sir.
me with the KVL for this loop between 18K and 9K. Please tell me what
minus
I should write.
minus I1 into
Minus
18K
I1 into 18K
minus I2
plus
plus I plus I2
plus
into 18
9. Yes.
Okay, so confirm for me, is it plus or minus?
plus, sir.
Plus, sir.
Plus, right? Because plus to minus is minus, minus to plus is plus. We do it like this. So of course, 18K we can take on the other side. So, and you can divide the whole. Okay, so we get 9K I2 is equal to 18K I1. We can divide by 9K on both sides, right? You will get I2 is equal to 2I1, right?
Yes, sir.
This is what I was telling you, that if you had guessed it, that hey, 9K is 218K is in parallel, you could have done it. But if you didn't, nothing wrong with it. KVL will immediately tell you that, right? So KVL told you that I2 is nothing but 2I1. So if you want, you can just write here 2I1. I'm just saying it simplifies things, right? So this one less variable. Okay. And then what do we do next? Anybody?
Between I2 and I3, we take another KVL, sir.
Perfect. So this time I will ask Jonathan for you to help me with this. But before I ask you to help me with this, let me clear this clutter, right? I will just remember this equation over here. That is 3I1 plus I3 is equal to 1 plus IL. Okay. So I will just quickly write it down. So 3I1 plus I3 is equal to 1 milliamp plus IL. Okay, we'll save this. So yeah, please help me with I'm sorry everything got erased, but we did assume currents were going up, right? And this was I2, this was I3, right? Okay, yeah, please tell me. So would you rather pick I2 and I3, or would you rather pick I1 and I3? And you can always
I2
do
and
the
I3,
loop
sir.
like this, right? Or you can always do the loop like this, whichever you like. Which is your preference?
I2 and I3, sir.
Okay, so please tell me the equation, right? So let me mark back what we missed,
Plus
right?
minus.
Okay, yeah,
Yes,
tell
sir.
me.
Yes. Yes, sir. It is minus 9K into I2
Okay,
plus 12K into I3 equals 0, sir.
perfect, right? So now I can sort of bring I2 on the other side. I can somehow divide by 9 or something like this, right? So what am I going to get? I'm going to get I2 is equal to 12 by 9, which is 4 by 3 I3, right? I2 is this, right?
Yes.
And then we had already found that I2 was nothing but 2I1, right? Since we are
Yes, sir.
converting everything into I1s, I will substitute 2I1 over here, right? And then I will get basically I1 is equal to 2 by 3 I3. Or if I say I3 is 1.5, I3 is 3 by 2 I1, right?
Yes, sir.
Okay, so now I can just go and substitute this back. So this becomes 3 by 2 or 1.5 I1, right? So 3 plus 1.5 is 4.5 I1 is equal to 1 milliamp plus IL. Now what do we do next? Anybody?
We take a loop between I1 and IL, sir.
I1 and IL. Great choice. And I have another thought for you, and I'm just wondering and asking, right? Would you consider taking a loop between I3 and IL? And what might be the advantage of a loop between I3 and IL?
Yes, sir.
Anyway,
I can take a loop between I3 and IL, sir. But both will be equal, sir. Current will be equal, sir.
Exactly. So I don't even need to do any looping, anything. I can straight away say it is not, it should be equal, right? So
Yes, sir.
I3
Yes,
is
sir.
going up, IL is coming down. So what will IL be? IL will be equal
IL
to,
minus of I3, sir.
perfect. IL is minus of I3. That's all. So what was the equation? Find this IL, right? Which is okay. If I find I3, I'm done, right? So I can even convert things back. So I found I3 was 3I1 by 2, right? Correct? Or 3I1 is nothing but 3I1 is nothing but 2I3, right? So maybe I could
Yes,
have
sir.
even replaced this with 2I3, right?
Yes, yes, sir.
So 2I3 plus I3 is 3I3. So instead of I1, I can talk about 3I3 is equal to 1 minus I3. Am I right?
Yes, sir.
So 4I3 is 1. So I3 is,
1 by 4.
yes, I3 is 1 by 4
0.25.
milliamps, a quarter milliamp, right? Milliamp. Okay. Now what is IL?
IL is minus 0.25 million.
Perfect. That's it. So IL is minus. That makes sense because they, these questions are tricky in that way. They wantedly pick the wrong direction. But it's okay. Even if it's the wrong direction, the answer is just minus. So let me erase all this stuff up, right? So IL is equal to minus 1 by 4 milliamps. Is it clear for everybody? And you see, we intentionally picked this loop because the resistors were equal. We knew it, right? So that made making the calculation very easy, right? So pick your I'm not saying, for example, right, if we had done this big equation, we would have still got the correct answer. Nothing wrong with it. It would have just taken a bit more loops, a bit more equations. The answer will still be the same. Okay. Or what you can also say, especially if things are in parallel, what do we say? Hey, the voltage across the parallel stuff is equal, right? So let's say I had this as my, voltage, whatever it is that it was, right? Oh, sorry, my bad. Like this, plus and minus, right? So I could have straight away started saying that, oh, wait a minute, this voltage is equal to this. Okay, so 18K into I1 is equal to 9K into I2, equation 1. This is equal to this. Okay, hey, 9K I2, sorry, is equal to 12K I3, right? Another equation. Ultimately, if you didn't think of it like this, when you do the KVL, you will get the same thing only, right? You will get basically, minus 9I2 plus 12I3 equal to 0, right? That's applying KVL. Or if you say, hey, basically, if you put a device in parallel, its voltages have to be equal, right? Then you can directly say, okay, 18K I1 is 9K I2. Now, can somebody tell me how would you say is equal in this case, right? So you have to say IL into 12K is equal to or minus of that because it's in the opposite direction is equal to 12K into I3. So long as you did this correctly, you can use this parallel method also. That means when devices are connected in parallel, all their voltages are equal. We used to use this equation that when devices are connected in series, all the currents are equal, right? Without writing KCL, every one point writing KCL, right? In the same way, I need not to waste my time doing lots of KVLs, right? It is like saying, for series connections, I keep on applying, KCL. Oh, I1 is equal to I2. I2 is equal to I3, whatever, right? So instead of doing all that, I just put I. In the same way, you can say, okay, for all this, the voltage is V. I pick a direction, plus minus. Or if you saw IL like this, you can say, okay, you know what? Already they have given IL like this. It has a plus minus. I'm just going to assume this is the VL, right? So everybody has VL. So I'm going to assume the direction like this coming down for everybody. It is okay. You will find the number is negative, but nothing wrong with it, right? And you can still do in the same way the equation. So Now you will simply say, oh, this is equal to this. So, if you call it I1, I2, you understand, right? What's the difference? It's the same. It's the same KVL. Now you can write it very fast. You can just say 9I2, 9K I2 is equal to 18K I1. You can just keep writing those equations, right? This is clear, the parallel part? I mean, if you're confused about the parallel, go back to KVL, okay? KVL will always work, 100% it will work, okay? But if you can do parallel and series, one less step, you will save one step. Sometimes saving those steps can somehow reduce the number of steps and less chances of error, okay? Okay, if no questions, let's quickly jump. Let's see. Oh shoot, I spent 1 hour on just 4 problems. That's not good. Okay, but I hope now we can start to speed up just a little. So let me go back here. Okay, the 4th problem was not too bad. Okay, it's too bad. I need to. Okay, I think I figured out the trick how I should do it. I should do like this, then I should go up, and now I can keep zooming and I'll get it. Okay, it is saying find the equivalent resistance RAB in this, right? So let us say you are really a fan of KVL and KCL. What you should do, you should apply a 1 volt, right? And just find the current I and then V over I, right? Is your answer. Or you can apply a current source of 1 amp, right? And simply find the voltage across this, right? And that voltage is directly your resistance, right? You can do it. So you can put a 1 amp current source, just solve the whole circuit, and that works, right? But another way, what we discussed last time, and I think you know this, is to do series parallel, right? So can someone help me with series parallel, right? So you see this branch, 2K, 1K. What is series of 2K and 1K? 3K, right? What is parallel of 3K and 6K?
2K.
Yes, it's 2K. 6 into 3 by 6 plus 3. Okay, which is basically 9. So 6 into 3 by 9. So 3 and 2. So this is 2. So this entire triangle is nothing but 2K, right? So
Yes.
now this 2K in series with 10K is how much?
12K.
12K, right? So you already found that this much is 12K, right? Now 12K parallel 16K is how 6K, sorry, is how much?
4K.
4K.
4K, right? Because what do you do? 12 into 6 by 18, 12 plus 6, right? So this is 3, this is 4. So up to this much is 4K, right? So what is 4 plus 2? The
6K.
series. 6K. 6 parallel 6?
3K.
3K. Very nice. So this is 3K, right? So you found this 3. What is 3 in series with 12? 12.
9.
Very nice. 12, right? Sorry, 3 in series with 9, 12. I was already thinking the answer in my head, right? So 12 parallel 4, right?
3K.
3K. Okay. 12 parallel 4, 3K. Very good. And 3 series with 2,
5K.
5K. 5K is your answer, right?
That's
I mean, this way we just did series parallel, kind of got it. But at the same time, you could have done, KVL, KCL, but I don't recommend it for this circuit. It'll take you a long time and you can make mistakes, right? So this is my suggestion of how we should do this. Okay. Any questions? Okay, good. Now let's come to this circuit. Okay. So, oh, I forgot to ask somebody. Okay. So now, Clinto Anticut. So you're next. So could you please share your thoughts on, in this case, you have to find all currents and voltages, right? And you can see there are so many currents and so many voltages, right?
This is my, can you hear me?
Yes.
Yeah, this is my first class. I just joined today, so I just have a
Oh,
basic idea about what's going on. So,
okay. No problem. Okay, we'll skip, troubling you for
no,
the moment. Let's go to the next candidate,
thank you.
Pavan. Sure, welcome. Pawan, do you want to unmute and maybe even turn on your video and you can explain to us how you would do this problem, how you think about
Yes,
this?
sir. Yeah, hello, sir.
Yeah, tell me.
Here a single voltage source injecting to all the elements
Okay.
with
Yes.
having three loops.
Yes, and we have three
So
loops.
clearly mentioning the currents.
And by the
Yeah,
way, right, it's good you saw three loops, and that's correct. You know, someone may think of this as a loop, this as another loop, this as another loop. So there could be more loops, but that's okay. Three is good answer. So three loops, okay.
yeah,
And the currents are all marked up, okay. So you're saying you're just
yeah.
going to apply
Need to
KVL,
find all.
KPL, just keep on applying it, and we'll do it, correct?
Yes, sir.
Yes, and I think that's a good strategy. Okay, so and absolutely nothing wrong with the strategy, and you know we will go ahead and do it like that too, right? And I like that idea,
Yes.
right? So, but what is the first step when you want to solve for this? You know, all the currents are marked, right? So what you need to do, you need to mark the voltage directions, right? Can you help me on the 9K? Where should I
Yeah.
put the plus? So this should be plus or minus?
Uh,
The left side.
Plus, sir. That should be plus from left.
Okay, 3K.
Plus
Left side should
minus.
be plus.
Plus.
Okay. 9K, left side,
Nine.
this 9K.
Sir? Yeah,
This
plus and
9K, right?
minus.
Plus and minus. Okay,
Yes,
very good. How about this 3K? It's already given. Okay, we don't need to worry about these. Okay.
already given. Yes.
So once you mark this, right, now you're ready to write all sorts of KVLs and KCLs, correct?
Yes, sir.
Okay, perfect. So, and we will do this in just 1 second, right? Certainly we'll do it. Just give me a second. But one more thing, you know what we could do? I know this is another cheat method, but hey, we just did a bunch of series parallel, right? Why don't we do it here, right? So help me. What is 9 series 3?
12 ohms.
9 plus 12. Sir.
12K, right? Okay. 12K in parallel with 4K is how much?
3K.
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 3.
Okay. 3K in series with 3K.
6K.
6.
6K, sir.
6K in parallel with 6K.
3K.
So here was 3K. Okay. And
12K.
3K in series with 9K.
12K.
12K.
Okay. So can anybody guess what is I1?
1
1.
ampere. 1 milliampere.
1
1
milliamp.
milliamp, right? Because these are all K. So I1 is 1 milliamp. Okay. Now let me uncover this, right? And say, hey, the equivalent here was 3K. So no, need not to do that. So I erase this, right? I come back here. You know that beyond this line, it was all 6K, correct? I mean, all of this rest was 6K. So basically 1 milliamp came here. Something came to this 6K, something went to the balance 6K. How much do you think came to this 6K? So what is I2?
Half milliamp.
Good answer, right? It's half milliamp. Of course, it's half milliamp, right? Because it'll divide equally. And even if, let's say you had a confusion, right? You can always say, hey, I have 6K, I have another 6K. You can apply KVL, whatever you want. You'll find that basically the net currents will be equal. So you'll find the I2 is half milliamp.
Sir, can
Okay.
you please repeat? Have you got I2 is half milliamp?
Okay, so let me repeat that, right? So I know I've marked it in a bad way, but if you see across this line, right, this line that I'm just redrawing again, right? Beyond that, the effective resistance of all this was 6K. That's what I have written over here, right? Because when we did the series parallel, right, that's how we found it, right? So the equivalent circuit of this, what we have here is basically 12 volts, right? In series with the 9K, right? And then there is a 6K. And then effectively the rest of this is equal to 6K, correct?
Okay.
And now I have 1 milliamp coming right through here, right? And so the question was how much goes here and how much do you think goes here? Of course, half goes here, half goes here, right? That's how I got it. Is it clear?
Thank you.
So,
Yes, thank you.
so then what we find is I2 is half milliamp, and we also find that I3 is
Half.
milliamp.
okay, great. You know, we are making oops, I didn't write it very well. Sorry about that. Half milliamp, right? And then how do you think I'm going to find I4? I'm going to say on this line, the whole of this, all this stuff was 3K, right? So, no, that's not helpful. This is not helpful at all. So what is helpful or what will be more useful is what was the resistance on this line. This line is not useful. This line is useful. This line, what I'm drawing now, right? This was 9 plus 3, 12K, correct? So now we have to see that, hey, look, I'm getting half a milliamp coming in here. I have a 4K ohm here and I have a 12K ohm here. How is the current going to divide, right? Of course, I can write KVL, I can do those things, right? And nothing wrong with it. Or I can realize that 4K is nothing but 3 12Ks in parallel. So 3 times of basically it'll divide 4 ways and 3/4 here, 1/4 here. If you do that, that's okay. Otherwise, you can apply KVL. I'm just telling you that sometimes for these painful problems, right, you can follow this kind of approach, right? If not, absolutely nothing wrong. What am I going to do? I'm going to actually try to, we can solve, we can write the KCL, KVL. It will not be difficult at all, right? But there will be a problem. You will have lots of variables. You just have to be extremely careful. That's all. Okay. So if you let's apply KVL on this loop. So can somebody tell me what is the KVL result of that loop? Pawan, can you tell me? Or
4.
Sir,
okay, maybe Kavya, you can tell me.
Let's say this node is I4 and I5 is nothing but C. Oh, sorry, B.
Okay. You want to
We
start from here or you want to start from the top?
start from the BB.
B, bottom, huh? Or top?
Top.
Top. Okay, start from here. Okay. So tell me. So please tell me the
Minus 9K into 5.
I5. Okay.
I5.
No problem.
I5 minus VC.
Okay. VC is what? 3K into
3K into I5.
3K into I5. Okay.
Plus
Then
4K.
plus
The
4K
current is in reverse direction.
into
I4
I4 is equal to
equal
0,
to
right?
0. Yes.
Or you can say, if I divide, basically I combine this, I will get 12K, right? Put it on the other side, right? And if I divide it by 4, I will get I4 is equal to, 12 by 4, which is 3
3
I5,
I5.
right? It's equation number 1, right? You found it, right? Now you can apply the next one, right? You can apply the next one. Then you can apply KCL, right? So can someone tell me KCL on, yes, question?
Sir, I have doubt. Because the current direction of I4 is reverse, right? When we are doing KVL.
Okay. So you
Is it to
see
be?
the current is going down, correct?
Yeah.
And when it is
Yeah.
going down, the tail is plus and the head is minus. Okay, right?
It should be minus I4, right?
No. Hold on. So I4 is going down, correct? And for down, this plus minus is correct, right?
No, I am saying KVL, sir.
Yeah, let's do the KVL, right? Now we start from here, it's plus and minus, plus and minus. So when we are doing plus to minus, it is minus. So minus 9K, minus 3K. Now you're going from bottom to top, right? When you're going bottom to top, do you see minus first or plus first?
Minus.
Minus, right? So if you see minus to plus, you have to add, not subtract, right?
Yeah.
So it is plus 4K, not minus.
We
Equal to
no
0.
need to check that current direction, right? We need to check the resistors, like it's going
No,
through.
you have to make sure that the current direction which is downwards, and the voltage plus minus is matching. That means if the current is going down, right, the tail must be plus, right, and the head must be minus. If this is correct, we are okay. That's all you have to check. Now we don't know if it will be finally down or up. In this problem, luckily they have given the correct directions. You will find all the numbers are positive. Nothing wrong with anything. Okay? Yeah. So, yeah, nothing wrong with this. The thing that you have to be most worried about, which you should never do, is if you put the direction down and if you put minus and plus, game over. After this, you're going to get all wrong answers. Okay? Okay. So in this way, right, just like we did I4 is 3, I5, you will find certain relationship between I3 and I2. With this, you will find a certain relationship between I1 and I2 with this, right? And then we can start applying KCL. So can someone help me do the KCL here? So Muhammad Navid, I haven't bothered you, so maybe you can help me. Help me do KCL for this node.
Yes, sir.
So what currents are coming in?
I3, sir. I3 and I2.
I3 and I2 are coming in, huh? Okay, well, these are going out actually, but that's okay. So I3 plus I2 is equal to what?
I1.
Very good. That is the KCL for this, right? Similarly, you can do a KCL for this second node, right? Which will be, again, Mohammed, please help me.
I3 equals to I4 plus I5.
I3 equals I4 plus I5, right? So in this way, you'll get these equations. You already know how I4 is related to I5, right? I4 is 3I5.
Yes, sir.
If you substitute it here, you will get 4I5. I3 is nothing but 4I5,
4I5.
right? So like that, you can keep
Yes, sir.
substituting, and with this combination of KCL and KVL, it won't be too complicated. If you do it beautifully, you'll get the answer, right? So we got I3 is 4I5. Okay. Oops. What did I do now? Sorry, one second. I lost my. Okay. Found it. Okay. So then if I substitute, what do I need to do here? I3 and I2. Yeah. First, I need to write the KVL for this middle loop, right? So can someone help me with the KVL for the middle loop? Starting. So let's see. Shivam. Oh, Shivam, can you help me with this? Okay, let's go to Obi. Hey, Obi, can you unmute and help me with this? Obi, are you there? Yeah.
Can
We
you hear
can
me?
barely. Yeah, can you say again?
The thing is minus VA,
Minus what?
VA,
VA, okay.
and then
So can you tell me from which point you're
plus
starting?
I3 into 3K.
No, can you tell me from which point you're starting and which direction you're going?
From PA, like minus
You're
point of view.
starting from this bottom node?
Yes.
Okay. And you're going clockwise or counterclockwise? Clockwise, right?
Clockwise. Yeah.
Clockwise. So when you go minus to plus,
Yeah,
you're
I'm
seeing
taking it up.
it's,
Yeah.
you're taking it as minus, huh?
Yeah.
Man, you want to go opposite to the class. Okay, go ahead. Minus VA. And don't,
Minus.
And my recommendation, right? These VA, VBs are names, right? So rather what you should do, you should say 6K into I2. Okay. So
Okay.
instead of this, I will just write minus 6K into I2. Okay, please continue. After that,
After that, plus I3 into 3K.
plus I3 into 3K. Okay.
And then it is plus I4 into 4.
4K equals 0. Correct?
Yes.
Or you can bring 6K I2 to the other side, right? So you will get
Yes.
6 I2 is equal to 3 I3 plus 4 I4, right? Now you have relationships between I3, I4, I5. You can keep substituting, right? You will now have a relationship between I2 and I5, right? Because I4 is 3 I5, right? So I can say here I4 is nothing but 3 I5. So 3 into 4, 12. So I'll get 12 I5. Okay. I3 is nothing but 4I5. Okay, so 4 into 3 again 12. So plus 12I5. So I will get 24I5, right? Is equal to 6I2, which is okay. 6 and 24 goes. So I'll get I2 is equal to 4I5, right? Now I am having more and more things with respect to I5. I2 is 4I5. I4 is 3I5. I3 is 4I5. I can substitute all of that, kind of into this first equation, right? But we still need to figure out I1. So we need one more loop. So if you write the KVL for this, right, we'll be able to solve it. I think you got the idea, right? So everything we convert it into one variable and build it up. Now once we have this one KVL and this one equation with those two equations, we'll figure out everything, right? Because now everything will be in terms of I5. Is it clear for everybody? So this is one way of doing it. This is the classic way and it is the correct way of doing it. Nothing wrong with it. Or you can do the kind of series parallel stuff, what I explained. Either way, which you are comfortable with, follow that. Okay. Any questions? Do you want me to solve the whole thing? I think you got the idea, right? Okay. So let's go to the next problem because otherwise we won't have enough time to solve all the problems. Okay, sixth one. Let's kind of come to, oops. Oh, sorry, I'm just messing up. Yeah, okay. Now let's come to the seventh problem. Oh, until now, things were mostly series parallel. Now we see some sort of really, really fun stuff coming our way, which is okay, right? Oops, I'm sorry. What did I do? Okay, and then I just go. Okay, let's look at it, right? So like I said, right, what we should do first, initial impressions, right? So look at the circuit, what's happening. Cool thing, there's one voltage source. There's a whole bunch of resistors all over the place. And that's it. It's just one voltage source and many resistors. So what's going to happen? This voltage source is probably generating current like this. And it's going to, just go in all directions, right? So there's going to be current going like this, current going like this, it's going to branch, all sorts of stuff is going to happen, right? So that's what this is. Okay, great. What do I need to do? I need to find V0, V1, and V2. So where are those? Okay, this is V2, this is V1, and this is V0. Okay, so we need to find, basically solve this, right? So, of course, the first thing I recommend is we can use, what do we say, KCL, KVL, right? But just now we realized that by doing series parallel, sometimes we can game the system and quickly get some answers and solve things faster, right? So what are you going to do in series parallel, right? What am I going to do here? So anybody can tell me in series parallel what tricks I can do here?
10
So we
parallel
can
to
simplify left side of the circuit, we can simplify into one circuit, one resistor.
Yeah, that's what I'm asking, right? How would you do it? So
This
10
10 kilo ohms is parallel with 20 kilo ohm.
in series
10
with
parallel 5, right? I don't see 10 parallel 20. Oh, this 10 parallel 20. Okay. So you do 10 parallel 20, 5 parallel 10, right? So
Yes.
let's do it. What is 10 parallel 20? Anybody? I'm sorry, what?
20K.
10 parallel 20 is not 20K, right? For sure.
6.6 ohms.
Very good. 6.6K. Or another way of saying it is 20 by 3K.
Yes.
Okay, very good. What is 5 parallel 10?
3.3 K.
3.3. Or let us just say 10 by 3, right?
Yes.
Now that these two have gone parallel, what do you do next? They combine in series, right?
Yes, sir. 9.9 K.
9.9K, right? So basically, it is not 9.9K. That's the mistake you.
10.
It is 20 by 3 plus 10 by 3, 30 by 3,
10.
which is 10K.
10K.
10K. Okay, so all this confusing resistor stuff, right, was nothing but 10K. Ugh, easy stuff. 10K. Okay, we put 10K here. Can we do something on the right side?
Yes, sir.
Help me simplify this, right? So how would you go about?
8
4.
and 4 series.
8 and 4 in series, okay. And how much is that?
12K.
12. And then
6 parallel with 12.
6K, very good. And then
Series.
series with 4, right? How much is
Yes,
it?
sir.
10K.
Yeah, series.
10K, right?
Yes, sir.
Whoa, how lucky are
7K.
we? 10K on both sides. You know what it means, right? If it's 10K symmetric on both sides, whatever be the current on this 10K, the same current on this side also. So great. Okay. And can I further simplify the two 10Ks? Anybody?
Yes, sir.
Yes, Kavya, go ahead.
Both are in parallel.
Both are in parallel.
Correct. So what is the net
5,
out of
5,
this?
5
5K.
5K.
So the simplified circuit, right, looks like this.
5 series with 3.
Perfect. 5 series 3, right?
Yeah.
And that's it with 16 volts, right? 16 volts. There is 3K, there is 5K, and we're done, right? This is something you can easily solve, right? So what is 5 series 3?
8.
8K. So I have an 8K resistor in parallel with a 16 volt source. What is the current going to be?
2 million.
Sorry,
2
say again.
2
4
milliamp.
milliamp. 2
2
milliamp.
milliamp.
2 milliamps, right? 16 by 8 is 2. So basically, this current is going to be 2. So there's going to be 2 milliamps shooting out of this voltage source, 2 milliamps in this way, right? It's going to come here, and there's 10K on one side and 10K on the other. Can
1
anybody
milli,
tell
1
me
milli. 1
one
milli, 1 milli.
and
1
one,
milliamp. 1 milliamp.
right? Done. So we already know it's 1 and 1, right? So that means there's going to be 1 milliamp coming right through here. Now, okay, we know that there is, so let me erase all the crazy drawings I made. Let me remark 2 milli, okay, 1 milli, 1 milli, okay. So it means also 1 milliamp. Now my question to you is, how much
0.5.
goes here
Half.
and how much goes
Half.
here?
0.5 milliamps.
Half, because it's 12 and 12, right?
Yeah.
So it's so simple, 0.5. Oops,
4,
milliamps.
4 kilovolts.
So what is the voltage here? What is V2?
4 kilo
4
ohms.
volts. Good job. Right? 8 kilo ohms into half a
4
milliamp.
volts.
4 volts.
Yeah.
Right?
Yeah.
Very nice. And on this side, we also needed to find V1. Can anybody tell me what is V1?
4
1
volts.
into
Also 4 volts, right? 1
4
milliamp
volts.
into 4 kilo ohms.
Yeah.
Correct?
Yes.
Yes, sir.
-4.
Wait a minute.
1.
Could we have made a mistake? What is V1?
-4.
-4.
Thank you. -4, right? Why? Because they have put the plus here and minus here. In reality, current is going like this. It's like this, right? So if this is +4, definitely this is -4, okay? So V1 should be -4. V2 should be +4. Let's now try to figure out V0, right? We have, first of all, we have a milliamp coming in. The cool thing is we don't care about this because the same milliamp will again come through this here, right? We just have to
Yes.
figure out between 5K and 10K how the 1 milliamp will split.
Half.
Can anybody tell me?
0.5 milliamps.
2
0.5?
times.
What?
2 times
No.
at V0.
Okay, so 1 milliamp is a total current coming in, right? How much on 5K? How much on 10K? Okay, if I'm confusing you, I'll simplify it and do it again, right? It's 2 by 3 and 1 by 3.
0.33.
And how do we get it, right? So basically, we say, hey, total current is coming in. So we need to just apply one small KVL here, right? Or like we said, hey, the voltage is going to be the same. It's in parallel, right? So whatever be the current coming into here and here, right? Let's call it I1 and I2. Then we can just say 5I1 is equal to 10I2. So basically I1 is equal to 2I2. And what is the total current coming in? It is basically 3I2 because I2 here and 2I2 here, so 3I2. So that means I2 is what? I2 is 1 by 3, right? And what is I1? I1 is 2 by 3, right? So 2 by 3 milliamps. I'm sorry, didn't I mix it up? Sorry about that. Silly me. 2 by 3, 1 by 3. Okay, so 2 by 3 milliamps into 5 volts is how much?
10 by 3, 3.3.
10 by 3, right? Another way you could have done is if you had remembered that 5 parallel 10 was how much? Was 3.3 or 10 by 3, right? So you could have said, hey, I have a 10 by 3K resistor and I have a 1 milliamp current. It's going to be 10 by 3 volts. That's it. That's the answer. So V0 is plus 10 by 3. V1 is minus 4. V2 is plus 4. Done. I mean, we did it with series and parallel. You could have, of course, also done it with KCL and KVL. But you now see that series and parallel is quite useful, right? So just to remind everybody, right, for some of you, if you don't remember, when resistors are in parallel, it is R1, R2 by R1 plus R2 is the effective resistance, okay? And always keep in mind that it will be smaller than the smaller resistor. So if I had 5K and 10K, right, whatever answer you get, it should better be smaller than 5K. If you got an answer more than 5K, you should immediately realize you made some error in calculation. You should recheck your calculation, okay? Same thing. So every time you do parallel, right, you should get less than the lower one. So 3.3 is lower than, okay, good. Suppose by chance you got 6.6. Immediately you know something, you made a mistake. Go back and check. Okay. So always remember in parallel, the resistance, effective resistance will be lower than the lowest resistor in parallel. Okay. So this is how you can do things. Okay. So I hope this series parallel was very clear, right? How to do this. Everybody, right? Anyone has questions, we can answer. Okay. So now we will go to the other side, right? And we will go full screen mode. Okay, for the circuit below, we just need to only find V0, right? So this looks reasonably straightforward, right? So how are you going to do it?
Bridge balance condition.
I'm sorry, what?
Bridge balance.
Series parallel?
Bridge balance.
Misbalance, what?
Bridge balance, sir. Bridge balance condition.
Bridge balance. Okay, so what do you do with the bridge balance?
Middle 12K open.
Okay, so what you're saying is, hey, look, this looks like an H bridge with perfectly balanced. So I already know that the current through this guy is going to be 0. That's your point, right? Is
Yes,
that what
sir.
you're saying? Yes, and that is correct, right? And definitely that will immediately simplify it. But let's say you don't remember H bridge or something, right? That's basically you'll find that it's perfectly symmetric. Like, so whatever current goes in here, you can assume the same current goes in here. Now, why? Why can I say whatever be the current going here is the same as here? Why? Because the circuit looks exactly the same. And not just in here, after it, when it comes back, right? It's again connecting in a very same way. So these two I's will be same. Although we cannot be sure, we know I1 and I1 will be same. Now we don't know if I1 is equal to I. In a way, it should be equal because if you see one from the top and one from the bottom, they are symmetric. But if you were able to think that much symmetry, then you will find that this I1 is nothing but I only, this I only. And immediately you'll realize since I have I, that means this middle should be 0, right? So that's what Mohan Krishna mentioned that, hey, this is an H bridge. It's a balanced H bridge. So I know that this resistor will have 0 current, right? So, but you know what? We are not going to follow all these tricks, right? We'll just do it. So what we could do, so long as if you can at least see this symmetry, I and I, let's do it with that. Later we'll do it without that also, right? And see what the answer we get. Okay, so let's in fact take this I, maybe I, and let's call this as, oops, I1, and call this as I1. right? And start applying the equations, right? So you'll immediately realize that 2I1 is equal to 4 milliamps. And you'll also realize that 2I is equal to 4 milliamps, right? That also should give you a clue that I is equal to I1, right? And both are equal to 2 milliamps. And as soon as you substitute that, you will find that this current is 0. You don't have to worry. You can figure out the voltages immediately. 2 milliamps into 12K is 24 volts, done, right? Let us say you didn't realize this symmetry business, right? Because this symmetry is very tricky, right? You said, okay, hey, I'm going to say I1, I2, right? And we need to keep going, right? So let's just call this, pick a direction, right? Let's say like this, I3, and we can just keep going down, I4, go down, I5, right? Now what you will find, few more variables, but it's still not bad. I1 plus I2 equals 4, I4 plus I5 equals 4, right? Then you start doing some KVLs, right? So you do a KVL through this, you'll find something, right? What are you going to find? So you're going to find that, or another KVL you can do, which will be actually much more useful. Okay, let's first do, because you can also do, so one KVL, another KVL here, or you can do this big H KVL, right? All of them. In this case, KVL is very easy because everything is 12K, right? So let's do first the little KVL, right? So you will find that plus, minus, plus, minus, plus, minus, plus, minus. Okay, so let's go from here. So voltage is increasing. So basically we will say I1, right? And then here it's decreasing, minus I2, okay? And here, when you go here, it's minus to plus, right? Plus I3 equals 0. I mean, it's actually 12K into I1 minus 12K into I2 plus 12K into I3 is equal to 0, right? Because minus to plus we have taken as plus. This is minus, again, this is plus, right? So you will find I1 minus I2 plus I3 equals 0. Okay. Now let's apply the same thing here, right? It's very easy. So minus to plus is plus. So I5 and plus to minus is minus, minus I3. And over here, plus to minus is again minus, is minus I4 equals 0, right? And then you also have, we have 1, 2, 3, 4 equations, and we need one more equation, then we can solve it, right? And that equation will be basically this giant loop, right? Which you can basically say, let's start from here, plus, plus, so that means I5 plus I1, right? Now it's minus, minus. So minus I2 minus I4, right? Or you can say equal to I2 plus I4. So now you have these 5 very, very simple equations, right? You can just quickly kind of, solve them. You see I1 plus I5 is equal to I2 plus I4, right? So if you I1, oh, this is already covered here. And wait, there should be one more which we are missing. Hold on, 1, 2, 3, 4, 5. Okay. So our equations are, we didn't apply KCL at one KCL equation is missing. We don't really need this big thing. We just need a KCL at any one point. Let's pick this point and do a KCL, right? So what is that KCL? I1 coming in, and I3 is going out, and I5 is going out, is equal to I3 plus I5, right? Similarly, over here, if you do a KCL, you will find I2 coming in is equal to I4 minus basically I3. I mean, I3 plus I3 should be I4, right? So now you'll start to find all your equations to kind of start to make sense, right? So now you can combine these equations however you want. And basically, you don't need both. You can pick any one. This is enough. You don't really need this. So this is 1, 2, 3, 4, 5 equations and 5 variables. I mean, the equations are straightforward only, right? So you can easily kind of substitute. Like I1 is I3 plus I5. Okay, here I can put it, right? I3 plus I2 plus I5 is 4. Okay, great. I took care of that. I've got rid of I1 here. Then I can get rid of I1 here as well. I1 is I3 plus I5, right? So basically I3, 2I3 plus I5 is equal to I2. I2 is equal to 2I3 plus I5, right? Okay, so we took care of this equation. Now I need here I3 is I5 minus I4. Am I right? I3 is I5 minus I4. So, and I5 minus I4. Or you can say that, sorry, but yeah, you can just keep solving, right? Keep reducing variables. So wherever you see I3, now substitute it with this. So 2I3 becomes 2I5. So that'll be 3I5 minus 2I4 is I2, right? And then you can, apply these equations one by one back. And as you keep reducing the variables, right, you will finally find one of the currents. As soon as you find one, you can just work your way backwards and solve for the rest. Okay. Of course, the symmetry method works really well, because if you can recognize that symmetry, that'll really help you. Or like Mohan Krishna said, hey, if you can figure out that I3 is 0, that really helps you, because as soon as you realize I3 is 0, I2 is I5, right? And I5 is I4. So you'll start equating. You'll find all the currents are actually equal. And then it's really easy. So there's 2 milliamps here, 2 milliamps here. That's what you'll find in the end. Basically, by solving all this, once you find I3 is 0, the rest will be very easy for you. Right? So this is how you do it. Of course, like I said, if you don't find the symmetry, if you don't, nothing wrong. Keep on applying KCL, KVL, get those equations, patiently solve them, you'll get the answer. But the cool thing that I want you to start thinking is exactly looking at this circuit and saying, look, it's perfectly symmetric. Whatever happens from this side seems to be same as that side, just happening in the opposite direction. That means if current is going in, whatever some current will come out, those currents should be equal for top and bottom branches, right? Further, if you realize that these two are going to be behaving in the same way, you're done actually. Then if you just wrote I and I, like we said, you solve it very fast. Any questions on this? And sometimes they come up with, I don't know if you have seen that question, like there is like, a resistor in a cube type of format, right? So each edge of a cube is sort of an R, if you will, right? And like this, oops. Like that, and then you pick one side from here, you pick one side from here, and you try to find the equivalent resistance, right? Same thing over here. If as soon as you realize that, look, there's a bunch of symmetry, these three should be symmetric, and you have to take the same I in them. And similarly, the I's coming here should be the same. You'll start to find that this whole insanely crazy circuit becomes much simpler to do. But anyway, we'll not do such bogus circuits. These are not really useful in IC design, right? So these are just interesting as a puzzle or a mathematical exercise, right? Not necessarily useful from a design perspective. So we'll not do this, but this is certainly a very useful circuit, the H bridge. Okay, great. So any questions on the 8th question? Sorry, any doubts on the 8th question? If not, let's head back and let's get to the 9th one. Okay, and you'll notice that it's this crazy H bridge coming right back at us again, right? And which is not going to be a problem. How are we going to do this, right? So here I would say, any ideas?
Convert the delta to star. Listen. Per pulse.
Delta to star. What?
Upper 18K, 18, 18, 18, convert to star.
Yes, you can certainly do it. So I think what is being proposed is, you're saying this
Yes,
can be converted to an equivalent
star.
like this, right? You can do that, right? And I don't question that, right? Alternately, if you sort of at least realize that, look, these two branches are okay. So that's definitely one way you could do it, right? Otherwise, you just say this is I1. So what is the current going here? 6 minus I1, right? Sorry, 3 minus I1. My bad. Oops. 3 minus I1, right? So similarly, pick a current here, right? Pick something. If it is going like this, there's got to be current coming down. So let's call this I2. So this is 3 minus I2, right? And then you can just mark some other current over here, call it I3. It's just 3 variables, right? So with 3 variables, you can first apply whatever, KCL over here, right? So what are the currents coming in? So this we should have assumed like this, right? So then only it will be I1. First of all, right, this is really a dangerous I1, if you notice, because the current source is pulling current like this. You can be almost sure that this I1 is going to be negative. Okay, but let's let it be what it is, right? And we have picked it like this. So let's follow with this direction only. Do not change in the middle of your analysis. So 3 minus I1 like this, I3 like this, I2. So what is the KCL? All three are coming in. So you have I2 plus I3 plus 3 minus I1 is equal to 0. This is one KCL equation you already have, right? You will get one KCL right here, which is I1 is coming in, and this dude is coming in as well, which is plus 3 minus I2 is really equal to I3, right? So you got these two equations, and then you can put, we need a third equation, which will be a KVL, right? Let's do a KVL across this loop, right? So the current direction going up, plus minus, going this way, plus minus, going this way, plus minus, right? So we write down the KVL. What is it going to be? 12 into I1, sorry, yeah, I1. It's going plus to minus, so I should do a minus, right? Again, plus to minus, so minus 18 into I3, and then minus to plus. So plus 6 into 3 minus I1, right, equals 0. That's it. By solving these three equations, 1, 2, and 3. And let's simplify this third equation, right? It's now looking very complicated. Let's put this 12I1 and 18I3 on the other side. You will find 18 minus, or 18 equals 6I1 plus 12I1, okay, plus 18I3. How fun. 1 is equal to I1 plus I3, right? So you got this equation also. You can now substitute I1 and I3, right? I1 is 1 minus I3. So you can just put here 1 minus I3, right? And then you will get this equation will become I2 plus I3 plus 3 minus 1 plus I3 equals 0, right? So the 1 you can take it to the other side, 2 I3s, 3 minus 1 you can take it to the other side equal to minus 2. You have 2 I3 and you have I2, right? This is one equation. Now with I2 and I3, so we already know I1 is 1 minus I3. I can substitute it here, 1 minus I3, right? So that becomes 1 minus I3 plus 3 minus I2 equals I3, right? So I can bring this I3 over on this side. It becomes 2 I3. 1 plus 3 becomes 4, right? So I get basically 4 minus I2 equals 2 I3. So now we know how I2 and I3 are also related. I can substitute this back over here, 2 I3. Luckily, I have 2 I3 already. This what? Okay, I'm sorry. I think I made a mistake. So we did this KCL, that is correct. So we got that relationship, we got this relationship. And then we just needed something to tie them together, which was this, which makes sense. Okay, I'm sorry, let me take one more stab at it, right? Let's do it cleanly one more time, one last time, okay? I1 is going here, so plus, minus. So let's say over here is our other current, which is 3. That's a mistake I made. It's I1 minus 3. Oops. Why? Because this current plus this current. So I1, let's just call it for a moment I2 plus I2. Both are in the same direction. Plus 3 equals 0. So I2 is equal to minus I1 minus 3. So that was a mistake I made. So that's why all my analysis went to dust. So no shortcuts. Minus I1 minus 3. That's the current going here. Okay. And this is I1. Sorry about that. We just do it correctly, then that'll work out. Whew. Okay, so let's just assume now I2 and let's take I3. That's it. No, we don't take I3. I'm sorry. What do? We try to say I2 plus I3 is equal to 3. So I3 is nothing but 3 minus I2. So we will write here 3 minus I2. Okay. So we just want to minimize the variable. So we have I2, we have I1. That is good. And here we can pick a direction, right? Pick something like, and say that maybe the current goes whichever one way and just call it I3. Okay. Now, at least one of the KCLs we should apply, which is this one, I2 coming in, I1 coming in, I3 going out, right? So I1 plus I2 is I3. So that's one equation, okay? And then what other equation we have? I think if you apply KCL here, we may get back the same equation, nothing new. So I don't think it will help, but we can just apply it, right? Coming in, coming in, coming in, all are coming in. So we just add them all up. So I3 minus I1 minus 3 plus 3 minus I2 equals 0. This goes, I think you get back the same thing. So yeah, you don't get back anything new. So this is one equation, okay? And then what else can I do? Now I need to apply some KVL. So I just applied 2 KVLs and I should be kind of on my way. So 1 KVL on this loop and 1 KVL on this loop, right? So let me apply this. So plus, minus, plus, minus, plus, minus. Over here, plus, minus, plus, minus. Okay. So let's first apply on the 18Ks. It'll be just so easy if we go around on the 18K, right? So from plus to minus, it's a minus. So minus I2. I'm just keeping 18K common out. So minus I2, again, minus I3. And then here again, plus, what is this?
3 minus 5.
Minus I2 equals 0. Oops, did my thing come correctly? Okay, let's put all the other stuff on this side. 3 is equal to 2I2 plus I3. This is one equation. We got two equations. We need a third equation, right? Which will be this bottom KVL. Okay, this will be a little tricky. What we will do, we will take 6 common out. So we'll call this as 1 ohm, 2 ohm, 3 ohms. So that'll make it very easy. So let's go from here. Plus to minus is negative. So negative 2I1. Here it is again negative, oops, 3I3. And then here minus to plus. So it's plus. I need not have put plus. Oops, sorry. It's sorry about that. Wow, why did I do that? 1 second. It's basically minus I1 minus 3, and the whole thing is equal to 0. So all the terms are negative. So I can just kind of take them to the other side, and I can collect 2I1 and I1. So it is 3I1 plus 3I3 plus 3 equals 0. Right? This is my last equation. Now we will be able to kind of solve this. Oh, sorry, wait, it went somewhere. Where did it go? Okay. So our three equations are in the box, right? I1 plus I2 is equal to I3. 3 is equal to 2I2 plus I3. And here 3I1 plus 3I3. So this can be written as I1 or sorry, just 1 second. Okay, so this is basically oh, come on. Okay. Sorry, my stylus is just giving me trouble. Okay, good. So basically I1 plus I3 is equal to minus 3. This is my last equation, right? This. So I1 plus I3 is minus 3. 2I2 plus I3 is 3, and this, right? So now we can start substituting or trying to figure things out, right? So let's first eliminate I1 between this equation and this equation. So we just subtract this with this, right? So we will basically, yes. Sorry.
I1 is equal to minus 6.
Yeah, so we will, if I subtract those two, right, I will get I2 minus I3 is equal to I3 plus 3, right? And if I bring the I3 to this side, I will get basically I2 minus 2 I3 is equal to 3. That is one equation, and this is my other equation. So if I now, combine these, so I have to multiply this by 2 and add them, right? Then I will get basically 6 plus 3, 9, right? So 9 is equal to, multiply this by 2 and add it, right? So 4I2 plus I2, it is 5I2. Now you can just keep going backwards, right? So you found I2 is 9 by 5. Substitute in one of the equations, you'll find I3. Once you know I3 and I2, you can just keep going. You can get I1 and you're done. Okay. Okay, so of course I'm also having trouble because I'm sorry I have to write on the screen. I want to keep the circuit also in place. I hope you will have a clean sheet. You'll be able to draw the circuit, right? And just write your equations below neatly and be able to solve them well. Okay. But the main point is that the math is not very hard and you can do it. So next, let's look at the 10th problem. It's just 3 more. We'll try to go a bit faster. We are just out of time, but I think we can do it. Okay. So it has a current controlled current source, this particular one, right? So basically it's saying whatever be the current here, 4 times as much current is going to go here, right? So what can I say about the net current coming in into both branches in parallel? What is the net current of these two? There is I naught, right? And there is 4 I naught going up. What is the net?
3 I naught.
3 I naught, right? So I can think of it as 3 I naught, right? Another way to think about it is, and 3 I naught is going in the opposite direction, right? So that's just something I can keep in mind. But how will I solve this, right? It's pretty straightforward. I just need to find Vs, right? There's a current source here, right? I need to find voltages and currents. So basically current will start splitting, right? There will be a current going here. Let's call it I1. There is I naught, 4 I naught, and we are done, right? So who can tell me what will be the KCL for this net? Let's pick someone new. Maybe Vidadala, Venkata, Sai Raghava. Which is your preferred name, Venkata or Raghava? Okay, I think we lost him. He gave up. Maybe any of you. So back to you, Nikita. You want to give it a try? So can you please help me with the KCL for this? So KCL for this node, please help me. What are the currents and how do we do it? So what is coming in? So this is going out. This is going out. What is coming in? You're on mute. I'm sorry. That's why we can't hear you. Yes.
4 I naught is coming in. I1 is
Okay.
going out. 10 milliamps also going out.
Okay. So 4 I naught is equal to what?
I1
I1
plus I naught plus 10 milliamp.
Perfect, right? This is my 1 KCL, correct? Very, very nice. And can I apply a KVL on this loop, right? So before I do that, I'll clean up some of my mess. Oops, we're going to lose the other equation. Sorry about that. So let's first say I naught is this way. So is this the correct voltage drop or the other way?
Correct, sir.
This is correct.
Positive negative.
Yeah, okay. And we did assume the wait, did we take I1 to be up or down?
Down.
Okay, down. Okay, let's take it down, right? I1. So where will be plus? On top or at the bottom?
Top will be plus.
And here already we have plus, minus.
Plus
Both will have
minus.
I1, right? So now we have marked all the resistors. Now we can do it. Let me just rewrite the equation what you told me. 4 I naught is equal to I1 plus I naught plus 10.
Plus 10 milliamp.
Right? Which is also saying that 3 I naught is equal to I1 plus 10. Okay? One equation. Then when we apply, please help me apply KVL on this, right? So what is that equation?
4 I1
4 I1, very nice.
plus 2 I1
Plus 2 I1
minus 3 I naught
3 I naught.
equal to 0.
Very, very good. Yes. So 4I1 plus 2I1 is 6I1, correct?
Yes.
So basically 6I1
Minus
equals 3I0,
3I0.
right? Or we can say 2I1 equals I0.
I know.
There. Once you substitute I0 is 2I1 into this equation, I0 is 2I1. So this is 6I1, right? So 6I1 minus I1 equals 10. So I1 equals 2, right? Milliamp, of course. How did I do it? 6 minus 1 is 5. 5, I bring it down here, so I get 2, right? I1 is 2 milliamp. If I1 is 2, I0 is 4 milliamps, right? And then as soon as you found I1 and I0, you have all the results. You can calculate V0. So can anybody tell me what is V0? In fact, we knew that as soon as we know I1. What is V0?
4 into I1, 2, 4, 8 volts.
Correct. 8 volts. Good answer.
Volts.
Clear for everybody, right?
Yes, sir.
Okay, super good. Now let's just 2 more problems. Sorry, today is going to be a bit longer, but I hope it will be a useful class for you. Now we will come down. Okay. Okay, this circuit, right? First of all, right, what do you start to notice when you stare at this circuit? We need to find VA. We've sort of marked what is VA, right? Which is good. We can figure out this VA, no problem. And looks pretty straightforward, right? So this time I will ask somebody else to help me. Anybody wants to volunteer? Yes, yes, Rajita, please help me with this. So how would you do this?
VA equal to
Okay, VA equals.
um
No, just tell me
2V
what you're doing. So you're saying you're applying KVL, KCL. What are you doing?
KVL, sir.
KVL, okay.
VA equal to
Minus
2Vx minus 5I. Assume as the series current.
But what is the direction of your I?
Uh, it's plus minus two resistance.
I mean to say, is the current going this way or is it going this other way? So this is
Yes, left
going
to
the
right.
Left to right, this way, right? You have picked it like this.
First one, sir. First arrow.
This first arrow. So you have
Yeah.
picked the direction like this. Okay. And which way should I put plus for the 5K?
From left side.
Left side. So like this, right?
Yes.
Is this correct? Okay. So when you did the KVL, right? Okay. So please help me understand how you got 2Vx minus 5.
It's a series, sir. Sorry, it's a plus.
Plus
2Vx plus 5K equal to VA.
Ki, right? And the way we
Yes.
have done it is just we do an imaginary voltage source here and we do
Yes.
this kind of KVL, right? So you will find
Then
it
after
became
I
this as
applying
plus,
the
right? Or you
long
say these
KVA.
two are in parallel, so you can just add up these voltages, right? So this is correct, okay? And then how do you solve for I?
By applying KVL through the circuit or
Tell me what will be that KVL
difference of
equation?
voltage by 5K resistance.
What is difference of voltage?
12V minus 36 by 5K.
So you're saying that Vx is 12 minus 36?
I, sir.
Huh?
I, sir. I.
Yeah. So
Because
are you saying 5Ki is equal to 12 minus 36?
yes, sir.
How do you know that?
Voltage difference. I applied the between 2 points.
Okay, which 2 points? These 2 points?
36 volts and 12 volts.
Okay, you took voltage difference between these two and these two.
Divided by resistance.
Why did you do that?
The current flow same as the because all the connections are in series.
Okay, so then you have to apply a full KVL, right? You cannot just
I
pick and choose, right? Now what you did, you just said, hey, I'll take 3 elements. I'll just ignore the other 3. I don't like the 3 elements. I'm not going to talk about it.
Okay, sir. I did both ways, so I just want to tell in simple way.
Yes, yes. So, this method, what you just told just now, right? I hope the class can recognize this is not correct, right?
Okay, sir.
You cannot ignore 3 elements just like that.
Okay, then I will apply the full KVL to
You
the
have to apply
circuit.
full KVL, right? And we will apply it in a moment. Absolutely right. But any reason why you pick the current to be like this direction?
Which direction, sir?
This direction. You said the current is like this, right?
I generally assumed from 10K ohm resistor to this way.
Okay.
Series. The first.
Yeah. So, but why do you assume the current is like this? Because usually we always do that.
Yeah.
Okay.
12 volts is deliver the energy, so resistance absorbs the current.
Okay. And how do you think about 36 volts? Do you think that will deliver any energy?
Which current?
36 volts.
Sir, I thinking about 12 volts.
Okay. And
I'm
that's reasonable,
answering
right?
about.
Like
I'm
I said,
answering.
right? Even if you assume a direction that ultimately is not correct, it's not a problem. You will
Okay.
still get the correct answer. Nothing wrong with
Okay.
it, right? So perfectly fine, quite reasonable. Let's keep assuming the direction like this. That means the current has to flow like this, plus, minus, right? And in this way, if you see how will the current flow, can you tell me? Plus, minus, right?
Yes, sir.
Because it's coming like this, it's going, so it's plus, minus, so all good, right?
Okay.
So now please tell me the KVL.
Yes, sir.
From
12.
which point you're going to, from 12, you're going to start from
I
here?
will start from 12.
Okay, so tell me 12.
12 minus 10i, 10ki.
Okay.
Yeah. Then minus 2vx.
Minus 2vx.
Minus 5i, 5ki.
Minus 5i. Okay, we'll leave the k for now. Don't worry.
Okay.
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 And
Plus
then
36.
Minus 36.
Oh, sorry, minus 36.
minus 36. Be very careful with plus and minus.
Yeah,
Okay, minus
yeah, sir.
36.
Yeah.
And then how about this?
It's minus vx.
Minus vx.
And 5i.
Vx is equal to 0, right?
Okay. Okay.
And then if we sort of collect the terms, right? What is 12 minus 36 is minus 24. We can take it to the other
24.
side. So we can say something is equal to 24, right? And what is equal to
3vx.
24? Basically minus 3vx,
Vx.
right? And
Minus 15i.
I, right? And also what is vx?
Vx is equal to 5i.
5i, right? So we can say is 5i. So what is 3 into 5i? Minus 15i also, right? So we will get minus 30i is equal to 24, right? So I is equal to
24 by 30.
Minus 1 point.
minus 24 by 30. Please pay
Yes.
attention to the minus, right? It's very, very important.
Sure.
So nothing wrong with it, right? We got a negative answer, which means this is 8 by 10, which is 0.8, right? So it's
Yes.
0.8 milliamps, right, is a current. And 0.8 milliamps minus, right? That means whatever direction we assumed, the actual current is in the opposite direction, which is okay. It is not a problem,
Okay.
right? Now we need to find VA. You said VA is this.
Yes, sir.
2Vx plus 5Ki. Now turns out
Yes.
Vx itself is 5Ki, right? So this is like 15Ki. Am I right?
Yes, sir.
So 15K into 0.8. So 15 into 0.8 into K into milli is volt, right? So what is 15 into 0.8? Or 15 into 8 by 10, right?
1.
$1.2.
2.2.
Yeah. 12, right?
1.2, sir.
15 into 0.8.
1.2.
15 into 0.8, right? So it will be 12, right?
Yes, 12. Yes, sir. 12,
1.5
sir.
into 0.8 will be 1.2. Okay.
Yes.
So 12. So whatever VA they are expecting, that is 12 volts. My bad. I'm sorry. Minus 12 volts. Please don't forget plus and minus. Okay. Plus and minus, very, very important, right? And usually, of course, in this case, perfectly reasonable. You could have picked this, right? But if you, and this is quite reasonable to pick this. And one reason why it's good to pick this direction, even though you know it's wrong, is because you know that in Vx, then it'll be easy. This will be the direction. Otherwise, you will have to be careful. If you pick the other direction, then Vx will be equal to minus 5Ki. Either way, right? So
Yes.
you already know that based on the two voltage sources, 36 volts is more powerful than 12. So definitely 36 is going to win. So the current is going to go the other way, right? Still, if you pick the other way, nothing wrong with it. You're just going to get a negative answer. Okay, so that's the answer. Answer is minus 12 volts. So basically this side is going to be more positive than this. So this VA is minus 12. Okay, last problem for the day. Oops, where am I? Okay, let me quickly come down to the last problem. Okay. So here, they are talking about a 10 volt source absorbs 2.5 milliwatts of power. Why is a voltage source absorbing power? Anybody? Huh?
Weak battery.
Bad?
2 minus. Bad battery. Battery.
Battery?
Because
Bad
the less
plus
voltage
2
is
minus.
lesser than the source voltage.
Sir, it's a resistor, sir.
No, it's not a resistance, it's a voltage source, right? Here, this is the voltage source. But why is this voltage source absorbing power?
It's less
Because
than the
it's
source
entering
voltage.
into plus positive.
Yes, Kavya, say again, what?
It is entering into the positive side.
Correct, the current is this way. Okay, and how much is the current? Can anybody tell me? How do you calculate that current?
2.5 by 10.
0.25 milliamps.
Okay, 0. And how did you get that 0.25 milliamps?
VI power is 2.5
P equal to
VI,
VI.
right? So you say 2.5 milliwatts is nothing but 10 into I, where I is in that specific direction, right? So you get I is 1/4 of a milliamp, like 0.25 milliamps, right? Perfect. So you already know the I that is going through the series circuit, right? Now the circuit is so easy to solve, right? Calculate VBA. So I think this you should be easily able to calculate, right? So you should, a VBA always put B on the positive side, A on the negative. So you should calculate the voltage like this, okay? So think of it like this, either run a KVL or, however you do it, but that's how you have to calculate the VBA, okay? And then power absorbed by the dependent voltage. So what is meant by that? Power absorbed by, so first of all, if the current is going
2Vx.
like this, it'll be like this, right? 2V,
X.
2Vx,
The power absorption, we have to find the
so
2Vx into I. Yeah.
2Vx into I, right? If you call this as I, right? So that means the I is going to flow like this. It's going to flow like this. So are we correct in saying that the power absorbed is 2Vx into I? Anybody, any corrections?
Minus I.
Yeah. And why is it minus? Because If the current is coming out of the plus side, it means it is giving power, not
Giving
taking,
power.
right? So how much power it is taking is minus 2 Vx into I, right? Now, of course, what you will find is Vx is negative, and that's why this power is ultimately going to be positive and it's going to consume. Why is Vs negative? Can anybody tell me? Without solving the problem, you can tell already that Vx is going to be negative. Why?
Direction is different from what we are
Yes,
visioning.
direction of what, Kavya? So current is like this, right?
Yes.
If current is like this, we already know the voltage drop will be like this.
Yes.
And they have marked minus plus in the opposite direction, right? So that means you know going in, if the current is coming this way, if the current is coming down, definitely Vx is negative. Okay. So what is Vx? Anybody? Vx is minus 10k into I. Okay. Don't forget the minus sign for Vx. So that's what is Vx. Vx is going to be negative of 10ki, just because you have marked the Vx exactly opposite to how it should be, right? So this is very, very important. Don't make this mistake. Otherwise, definitely you will solve this problem and get the wrong answer, right? If you assume that, oh, my IR drop, if you assume Vx was 10k into I, and you assume this is the direction of I, game over. You're going to get wrong answer. Definite, right? No escape. So be very careful. This is to double check and test your assumption. So we already told you the direction is going this way. Why we told you the direction is this way? Because it absorbs
the
power, right? So you know the direction. Once you know the direction and the series connection, the current has to flow like this. If the current is flowing like that, the resistor drop is going to be like this. 10ki is plus on top, minus at bottom, not like this. What it means, Vx is really minus 10ki.
Minus 10.
Just pay attention to this, okay? Sometimes when it is given, right, if you blindly use Vs, be a bit careful. Vx is minus 10ki, that's all. Now you know why it is minus, right? Of course, now it is easy to solve. Once you apply KVL on this loop, you already know the current, right? It's a quarter milliamp. So this is going to be half a volt, right? This we'll figure it out. This is going to be 0.75 volts. This is going to be 2.5 volts, right? And this is going to be 1.25, right? Of course, we should mark the directions, right? Plus, minus, plus, minus. Of course, here the real drop 2.5 is going to be like this. Vx is going to be minus 2.5. So this is going to be minus 5, right? Clear, everybody? So if you, of course, apply the KVL on this, you'll be able to figure out what. Wait, you don't need to figure out. Already you know the current, right? It was already given to you. Okay? Clear, everybody? So one very important thing to understand always, please pay attention to direction. So if you assume current is in a certain direction, let's say like this, mark up always the voltages, right? As soon as you start doing it, you'll realize, uh-oh, whoops, something funny is happening here. Then you can pay attention. Vx is just shown like this. Vx doesn't mean Vx is positive. Vx can be negative also, right? So in this case, we know already that Vx is definitely negative. Okay, good. So I hope now, right after this, we are expecting all of you to be extremely comfortable with applying KCL, KVL, solving circuits with resistors and voltage, current sources, and so on, being able to do series, parallel resistors, and all of this comfortably, right? And like I said, in some problems, we were really also hoping that you are able to see some symmetry that will help you to solve the problems faster. Like I said, you don't have to, but if you see the symmetry, it will help you. Like, especially this H bridge problem, Or like Mohan Krishna mentioned, right? Hey, look, I know this current is going to be 0. Whoops, if this current is going to be 0, this is just like an open circuit. I can ignore this resistor. Then it's pretty straightforward. 24K in parallel, that's effectively 12K. 4 milliamps over 12K, you can find the current, then you can do easily all the math, right? So that's one way, or if you figure out the symmetry, that's another way. If you don't figure out all of that, not the end of the world. You can apply KCL, KVL and still, get the answer. Okay, any final questions, any doubts, anybody? And one last question, if anybody still needs a bit of help. Now I know one or two of you, like Clinto, you just joined. I request you to go and review all the lectures, right?
Okay, sir.
And then you will get a good idea of how to do this. If any of you still have questions, right, you can always reach out to us. Between myself and Dr. Krishnakant, one of us can, certainly help you. So with this, we are assuming that resistors and voltage sources and current sources, series, parallel, all this you're comfortable. We did cover inductors and capacitors. That is a bit hard, we understand. So we're going to cover it a little bit more again to make you guys all very clear and strong in those. And one more thing, I hope you remember all the concepts we talked about, which was DC analysis, AC analysis, nonlinear, right? How diode behaves, how MOSFET behaves. Basically, the way we solve those problems is by finding which region we are in. So don't worry, we will do more practice problems and to help you do it. But the way you do those nonlinear devices is you simplify the equation and you assume you're in some region. Assume you're in region X, right? And turns out you solve it and you check, am I in region X? If it turns out no, that means that assumption was wrong. That means scratch it now, assume you're in some other region, right? And solve it again. This is how you usually do diode problems or MOSFET problems. You need to kind of guess which region you're in, and later you need to verify. Only if you sort of are in the correct one, it will match up. If you assume wrong, right, the results won't be consistent. So yeah, so that's it. So once you're comfortable, because this KCL, KVL will keep on coming throughout now for all circuit analysis. KCL, KVL, you should just know by heart, like even in your sleep, if he asks you some KCL, KVL, don't make mistakes. Okay, and good. So then all the best. Next week, again, Dr. Krishnakant will be back. He will be teaching you the next, next topics. Any questions, anyone?
So 25th September class video was not uploaded.
Yes, sir.
Oh, 25th not uploaded. Okay.
Yes, sir.
I will remind them to upload it. No problem. I'll take care. Okay, we will do it.
Sir,
Anything
one doubt,
else?
sir.
Yes.
Pardon me, sir. Sir, in the last question, we took Vx is equal to minus 10K I, right, sir?
Yes.
Sir, how are we getting it negative, sir? I'm not able to understand that point.
Okay, it's a good question. Let's go back to it, and I think it's a fair question. Let's try to figure it out, right? So okay, perfect. Let's go to full screen mode, and here we are, right? So basically, what this first line, sorry, the wrong device. So what this first line told us, right? The 10-volt source is absorbing 2.5 milliwatts. So what does it mean? It means usually the voltage source will push out current, right? It will push current
Yes,
out
sir.
from the positive side, right?
Yes,
That
sir.
is when it is supplying power. When
Yes,
it's
sir.
up, so that part you are clear, right? So that
Yes,
we
sir.
will not cover again. Okay, that is clear. So then what we know is, we know for a fact that, oops, let me erase everything. Okay, we know for a fact that current is going in this direction. You agree with this, right?
Yes, sir.
Okay,
Yes, sir.
so given this situation, how do you think the current is flowing on the 10K resistor? Is it going down, you think, or is it going up?
Going down, sir.
Going down. Okay. So let's say it's going down. Okay. So if the current is going down, let's call the current I, right? Which
Yes,
is the
sir.
positive of the resistor and which is the negative of the resistor?
The top is positive and the bottom is negative, sir.
Okay. Top is positive, bottom is negative, right?
Yes, sir.
And what
Yes,
is
sir.
that voltage drop equal to in terms of the current?
Vx equal to 10K I, sir.
Wait, don't say Vx. You say
Yes.
voltage drop on the resistor is 10K into I. You agree with this, right?
Yes, sir. Yes, sir.
Now, what is the direction of the voltage drop? Plus on top, minus at the bottom, right?
Yes, sir.
For Vx, where is the plus?
Bottom, sir.
That means how is Vx related to voltage drop on the resistor?
Opposite of the voltage drop of the resistor.
Correct. So Vx is minus of 10Ki.
Yeah. Okay.
Yeah, got it. That's only
Got it,
because
sir.
they have specifically given this direction plus minus for Vx, but the actual direction for the resistor is like this. We know that for a fact, right? Because the current is going in this direction.
Thank
Okay,
you, sir.
is it clear?
Yes,
Yeah,
sir. Yes, sir.
good,
Thank you.
good question. Actually, this is how do I say, the difficult part of this. So some of these questions, they may look simple, right? But these are the dangerous things. If you make mistakes here, things will start to go wrong very fast.
Okay.
So
Thank you.
yeah, so the other lesson is pay attention, plus and minus, be very careful. You make one mistake, one plus into minus, game over. It's like, doing accounting, one debit, you make it a credit, or one credit, you make it a debit, gone, right? It won't work. So same here, directions are very important. Okay.
Okay, sir. Thank you,
Excellent.
sir.
Welcome. Good question. Anybody, any other questions? And it could be in any of the topics or any of the problems we solved today, or anything from this week. We can take 2 minutes, otherwise we'll close. I know we are already half an hour over. Okay then. Hey, I will not hold you guys any longer. So please have a good weekend. Please practice. I strongly recommend even those of you who did not submit the homework, please go ahead, do the homework and submit it. The people who at least submit it now, right? Let us say by this weekend, right? We will still give them at least 50% credit, right? Otherwise, you'll just get 0, which is not good, right? So please try to submit the homework. Okay.
So
Yes.
previous one, the homework I have submitted only few problems only, and there
Okay.
are some mistakes. So can I correct it and resubmit it, or I have to just leave it like that?
No problem. You correct and resubmit.
Okay, thank you.
No problem. Yeah. Now that you understood it better, right? You try to do it again and you can resubmit. No problem. Yes.
Okay.
And
Thank
try
you.
your best to attempt all the problems, right? And if you or any of you are finding difficulty with some problem, even after this class, of course you can review the recording. But if not, you can still put a message or write to us. We will, try to clarify any doubts you have. Okay.
Okay. Thank you.
Sure. Okay.
Thank you, sir.
Okay. Thank you. Thank you, everyone. I'll stop sharing and
Thank you, sir.
have a good night.